Welcome to qnawire.
So here we have two charges. One is zero point 0.5 nanocoulomb, and this is placed at a distance of 1.2 meter from another charge having a value 9 coulomb. So this is the distance, and d is given to be 1.2 meter. Now we are supposed to find a point in between these two charges or anywhere else such that the electric field at that point will be equal to 0. Now, as I said, the point should stay inside these two charges, in between these two charges, and the reason behind that is both of these charges are positive. They have the same sign, which means that only uh, at some point in between these two charges, the electric field will be 0. Now, mathematically also, we can explain this. So, let's say that the point where the electric field is calculated is at a distance r from this charge, zero point 0.5 nanocoulomb. Let's call this point P. Therefore, the rest of the distance, or the distance between point P and the 8 nanocoulomb charge, will be equal to 1.2 minus R, assuming R is in meters. Now, as I said before, both the charges are positive, so the null point will be in between them, and that point we have assumed to be at a distance R from one of the charges. Now, since over here electric field is 0, so we have E1. Let's call this point 1. Let's call this point 2. So E1 vector plus E2 vector will be equal to 0, because this is the net electric field at point P. So this means, let's calculate each of these fields. So E1 will be equal to 0.5 nanocoulomb, that is the charge, times K over R square, and the direction of this field over here will be towards right. So assuming our positive x-axis to be towards right, therefore this will be in the positive direction. Now E2 vector will be equal to k times charge over the distance, square of the distance, and that is 1.2 minus r whole square. And this field at point P will point away from this charge because it's positive, so it will point towards the left. And hence, as according to our coordinate system, assumed coordinate system, it will point in the negative x-axis, hence a minus sign before that. Now, notice that I have written the charges in units of nanocoulomb. So, in most of the situations, you have to convert this into coulombs before solving it. So, make sure you do that. But over here, this is going to be an equality equation where these charges, the units will cancel out. So, it doesn't really matter whether you convert these two or not. But when you are calculating the electric field or force or anything where charge is involved, you need to convert the coulombs into, you need to convert the unit into standard units like nanocoulomb to coulomb. So this will give us 1.2 minus R whole square over R square to be equal to 8 nanocoulomb over 0.5 nanocoulomb. Now, as I said before, these are going to cancel out, the units are going to cancel out, and this ratio will be a constant and will be equal to 16. Hence, it doesn't really matter if you convert these units or not. So, this will give 1.2 minus r over r to be equal to root over of 16, and that is equal to 4. So now as you can see, we have an equation in terms of r. So we can solve for r, and r is going to be equal to 0.24 meter. So now we can say that the electric field will be 0 at a distance 0.24 meter from the charge 0.5 nanocoulomb on the line joining them. Thank you.